Assalamu alaikum students. Today we will start with a new we'll study new chapter, measures of relationship between variables. Here the first concept that we will study is covariance. Covariance is a measure of the linear relationship between two variables. A positive value indicates a direct or increasing linear relationship, and a negative value indicates decreasing linear relationship. That means if covariance is positive, in that case if x go up, variable y will also go up. If x go down, y will also go down. That means if movement in one variable will lead the other variable to move in the same direction. That means both x and y will move in the same direction if covariance is positive. That means if covariance is positive, both x and y will move in the same direction. That means when they go up, they will both go up. When x go down, y will also go down if the covariance is positive. If covariance is negative, then relationship is opposite. That means if x go up, y will go down. If x go down, y will go up. That means if one of the variable goes up, the other variable will go down. That means opposite relationship. That means they will move in the opposite direction. So that means movement in one variable will lead the other variable move in the opposite direction. So this is covariance. Covariance provides direction of relationship only, not strength of relationship. That means from covariance you get only direction of relationship. That means if covariance is positive, that means both the variable will move in the same direction. If covariance is negative, both the variable will move in the opposite direction. That means you are getting from covariance you get an idea about the direction of relationship. But how strong the relationship, we don't get this idea from covariance. So the formula for covariance is covariance between variables x and y. You can only measure relationship between two variables only. That means covariance between x and y. That is, in short, we can write it, if it is population covariance, that means in that case we will write sigma xy. If it is sample covariance, we will write sxy. So here I have written the sample covariance formula. If it is population covariance, we will here use 1 divided by n. If it is sample covariance, we will use 1 divided by n minus 1. So this formula is summation of xi minus x bar. So that means deviation in x from the mean and multiplied by deviation in y from the mean. So 1 upon the other formula, another shortcut formula that we can use is 1 upon n minus 1 multiplied by summation of xy minus summation of x into y divided by summation of x into summation of y divided by n. So this is the other formula. In our note, in this course, we will use the second formula because this is the easiest. Right. So let us turn over to page number 2. Right. So now we will study correlation. Correlation measures both direction and strength of a linear relationship between two variables. That means when you calculate correlation, you not only get direction of relationship, but also you can measure strength of relationship. If the increase in one variable results in the corresponding increase in the other variable, that means if the changes are in the same direction, the variables are positively correlated. That means like the covariance, here also if correlation is positive, in that case if x go up, y will also go up. If x go down, y will also go down. That means like covariance, here positive correlation means both the variable will move in the same direction. If one goes up, the other will also go up. If one goes down, the other variable will also go down. Right. So example of positive correlation. For example, as the temperature goes up, air conditioned cells also go up. because if the temperature go up, that means we are getting warm, we are getting heat. That means we will need more air condition, and for this air condition cells will go up. That means if the temperature goes up, air condition cell will go up. That means temperature, if we consider temperature as x variable, if temperature go up, air condition cell y, if it is y variable, this will also go up. If temperature fall, that means if we get colder, in that case AC cell, air condition cell will also fall. So that means temperature and air condition cell both are positive, both will go up and both will go down. That means both of the variable will move in the same direction, right? So that means these are positively correlated. Studying hour per day. If you consider this as x variable, if you study more and more per day, in that case obviously there is a chance that your grade will be better. That means grade will go up. That means studying hour per day. That means if a student study 3 hours per day, for example, if one student study 3 hours per day and another student study 5 hours per day, so obviously the student who will study more hours per day, and his or her grade will be better than the other student. So studying hour per day, if you study more and more hour per day, in that case grade will be better. If you study less and less hour per day, your grade will be worse. Your grade will fall. That means these are positively correlated. If the increase in one variable results in the corresponding decrease in the other variable, that means if one variable goes up and which will result in the other variable go down, that means if both the variable moves in the opposite direction, the variables are negatively correlated, exactly like covariance. That means if one variable goes up, the other variable will go down in negative correlation. If one goes down, other will go up. That means negative correlation. Example of negative correlation can be, for example, absences in class. If absences in class goes up, grade will fall. That means if you remain absent for more and more classes, in that case your grade will fall. That means absences in class, if you consider it as x variable, and if grade is y variable, in that case if x go up, y will fall. That means negative correlation. If one goes up, other will fall. Absences in class, if absences in classes reduce, grade will be better. There is negative correlation. Temperature. If temperature fall, heater cell will go up. That means temperature fall means if you get more and more cold, in that case you will need more and more heater for your home. That means heater cell will go up. That means these are negatively correlated. That means if with the fall in temperature, you will need more and more heater. So let's see the formula for correlation coefficient. So this is correlation coefficient is denoted by, if it is a sample correlation coefficient, we will denote it by small r. So small r bracket x comma y, which means correlation coefficient between variable x and y. So if it is sample correlation coefficient, we will denote it by small r, and if the variables are x and y, then r bracket x comma y, which means correlation coefficient between x and y is equal to, the formula is sxy divided by root over sxx multiplied by syy. Here the formula for sxy is equal to summation of xy minus summation of x multiplied by summation of y divided by n, and root over sxx, the formula for sxx is equal to summation of x square minus summation of x whole square divided by n, and the formula for syy is equal to sum of y square minus summation of y whole square divided by n. If after you calculate correlation coefficient, you will see that the correlation coefficient value ranges between -1 to +1. It cannot be more than 1 and it cannot be less than 1. right? It cannot be less than minus 1. So when correlation coefficient is 0, that means there is no linear relationship between x and y, but not necessarily a lack of relationship. That means what we are saying, that correlation coefficient 0 means there is no linear relationship, but there can be relationship, but we are only saying that there is no linear relationship between x and y. So if the correlation coefficient value is plus 1, it indicates perfect positive correlation. If the value is minus 1, it indicates perfect negative correlation. So now let us turn over the page. We'll move to page number 4. If the correlation coefficient value is between plus 0.7 to plus 1, we will say strong positive relation. If the value is between plus 0.5 to plus 0.7, we will say medium positive relation. If the value is between 0 to 0.5, we will say weak positive relation, because all these are positive. As I said before, covariance measures only direction, but correlation measures also, correlation coefficient not only measures direction but also measures the strength of relationship. So from the value itself you can understand how strong the relationship it is. That means if the value is between plus 0.7 to plus 0.1, we will say strong positive relationship. That means from the plus sign we understand the direction of relationship, and from the value we understand if it is 0.7 to 0.1 we will say it's strong. If it is 0.5 to 0.7 we will say medium. If it is 0 to 0.5 we will say weak positive relationship. Similarly, if the value is between 0 to minus 0.5 we will say weak negative relationship. If the value is between minus 0.5 to minus 0.7 we will say medium negative relationship. If the value is between minus 0.7 to minus 1, we will say strong positive relationship. That means from the positive sign you can understand positive relationship. From the negative sign you can understand negative relationship. And if the values are between 0 to 0.5, we will say weak. If the values are between 0.5 to 0.7, we will say medium. If the values are between 0.7 to 1, we will say strong relationship. The problem with correlation is correlation does not imply causation. That means from correlation coefficient we don't understand whether x is influencing y or y is influencing x. We only understand relationship is positive or negative. We understand strength of relationship. But who is affecting who? That means if the x is influencing y or y is influencing x, we don't understand. That means who is affecting who, we don't understand from correlation coefficient. For that, we need to do regression. Regression measures the probable movement of one variable in term of the other. That means regression measures the probable movement of one variable in term of the other variables. That means from regression we can understand how one variable will move with respect to other. That means effect of one variable on another variable we can understand from regression. Therefore regression is used for prediction or forecasting purpose. That means if you want to predict something or forecast the movement of any variable, we can do regression. Regression is used to determine causation. Suppose the movement of the variable y is dependent on the movement of x. Suppose the movement of the variable y is dependent on the movement of x. That means movement of y is depending on the movement of x. In that case, here y is dependent variable because y is depending on y. That's why y is dependent variable, and x is independent variable. That means here x is affecting y. That means x is independent variable, and since y is depending on x, y is depending on x, that's why y is dependent variable. So regression equation can be written as y is equal to a plus bx, or it can be written as beta 1, beta is the Greek letter, beta 1 plus beta 2 x. So here A is similar to beta 1, B is similar to beta 2. Many people write it in different way, but both are same. With error term, if you include an error term, the equation will become a plus b, y is equal to a plus bx plus ui. Similarly here also we will include an error term, ui. As you know that only our creator, Allah or God, whatever you say, he can only forecast correctly. Human cannot forecast correctly. No human can forecast correctly. So that's why if you do some forecast based on any model, based on any quantitative model or anything else, there must be some error. So here forecast error is U. Forecast error means actual minus forecast. That means actual value minus forecasted value. If you deduct forecasted value from actual value, you will get forecast error. Right. So now we will move to page 6. Sorry, page 5. So regression equation we have already studied. Here y is the dependent variable as it depends on the movement of independent variable x. There are different synonyms of dependent variable and independent variable. Dependent variables are sometimes called regressant. Sometimes they are called, dependent variables are called response variable, target variable, predicted variable, endogenous variable. These are all dependent variable, different names of dependent variable. Synonyms of independent variable, some people they call it regressor, some people they call explanatory variable, predictor, exogenous variable. Right. Here in the regression equation, beta b0 or a or beta 1 is the intercept. In this equation here a or beta 0 or beta 1, these are all same. Some people they write regression equation like a plus bx plus error term. Some people they write it like b0 plus b1 into x multiplied by epsilon I. It's all same. Here epsilon is similar to u, error term. Here some people they write regression equation like in Greek notation beta 1 plus beta 2 multiplied by x1 plus the error term. So here a is similar like b0 is similar like beta 1. These are called intercept. Or some people they call it constant, since this is a constant value. It shows the average effect on dependent variable y of all the independent variables excluded from the model, or the average value of y when independent variable is x is 0. That means you will get, for example, if you put the value of x is equal to 0, for example, there is no error term. In that case, if there is no error term, in that case, if you put the value of x is equal to 0, that means this one is equal to 0, there is no error term, so that means you will get the intercept, that is beta 1 or a or beta 0. That means if the value of x is equal to 0, in that case you will get intercept. That means if the explanatory variable is 0, in that case you will get intercept. B1, B or beta 2 is called slope. That means whatever you have with the variables, that means here with the coefficient of the variable is b. Similarly here the coefficient of the variable is b1, coefficient of the variable is beta 2. These are all same. So that means some people they write it like b, some people they write it like b1, some people they write it like beta 2. Whatever way you write, these are slope. If you get something with the variable, this is called slope or regression coefficient. This is called slope or regression coefficient. This regression coefficient measures the change in the average value of y for per unit change in x. That means it measures the extent of increase or decrease in y for per unit change in x. So that means, for example, there is no error term. In that case, if you increase the value of x by 1 unit, you will see that you will see the impact on y by beta 2. That means if you increase the value of x by 1 unit, you will see from beta 2, you will see that how many units of changes in y you will see from the beta 2. So beta 2 will give you an idea about the change in y with respect to per unit change in x. So let us move to next page. Regression coefficient. The formula for regression coefficient or slope, some people they write it like beta 2, some people they write it like b1 or b, whatever way you write. The formula is summation of xy minus summation of x into summation y divided by n, which is some sxy, and divided by summation of x square minus summation of x whole square divided by n, which is sxx. And the formula for intercept, some people they write it like beta 1, some people they write it like a, some people they write it like b0. How we get it? We get it by y bar minus b x bar. So b is the slope or regression coefficient. So y bar minus, some people they write it like instead of b, they can write it like beta 2. Some people they write instead of beta 2, they can write b1. So whatever way you write, this is the formula for intercept. So let us solve one question here. This is example 1. The table below shows average math scores achieved by 10 randomly selected Primicia University students in their business math course along with their scores in business statistics course. So here we have selected 10 students randomly from Primicia University, and this is their business math score and this is their business stat score. So for example, student 1, he or she got 39 in business math, whereas in business stat he or she got 65. Second student, he or she got 43 in business math but 78 in business stat. So 10 students, their marks in business math scores and their marks on business stat course is given there. So common idea behind this table is, normally business math course is taken first, then students do business stat course. That means before taking business stat course, a student must take business math course. And if a student has solid background in business math, that means if a student is good enough in business math course, in that case he or she will obviously perform better in business stat course. That means we want to see that impact of business math score on business stat course. That means this is the independent variable, this is the dependent variable. So we want to see how business math course, how score in business math core effect in business stat score. Okay, so that means we have a common idea that if a student is good in mathematics, he or she will perform better in business stat course. So we want to establish a causality here. So first of all, we need to input this data in calculator, right? So let us learn how to input this data in calculator. So data input, press mode in your calculator. First of all, I will show you how to do it using if you are using old calculator. First of all, I will show you how to input data in old type of calculator. So that means this type of calculator. So first of all, I will show you how to input our data set if you have this type of calculator. First of all, you need to press mode. So mode is there. You can see mode is there in the calculator. If you press mode, you will get you have to press mode twice. That means you will press mode and again mode. So if you press mode twice, you will see this display. So here when you get this display, after pressing mode twice, you have to choose regression. That means REG means regression. So you will choose 2. That means you will press 2 in your calculator. So after you press 2 in your calculator, after you press 2 in your calculator, that means if you after you choose the regression mode, you will get this display. So here you will choose LIN. That means you will press 1 to choose LIN. LIN means linear regression. After that, you will start inputting the data. So let us see the data. Let us check the data. So here the first data. The first data of X is 39 and first data of Y is 65. So you will first press 39. So you will first press 39 in your calculator, and then you will choose comma. So you can see there is a comma button. There is a comma button above the delete button. So you will press comma. That means first you will press 39. That is the first X data. And then you will press comma. This is the comma button. This is the comma button above the delete button. And then you will choose the first Y data, that is 65. Right? So after you get this, after you input the first set of X data and Y data like this, you will check whether the input is correct. If you see the input is correct, then you will press M plus button. This is the M plus button above the AC button. This is the M plus button. So if the data input is correct, you will press M plus button. So after you press M plus button, you will see the display shows is n is equal to 1. That means one data has been taken inside the memory. Right. So second set of data is X is 43 and Y is 78. So similarly, you will put second data is 43 and 78. So that means 43 comma 78. Like that way you will input the data, and then you will press, like before, you will press M plus. That means you will first input 43 and then you will put comma and then 78. If the data input is correct, you will press M plus. So when you press M plus, you will see the display shows is n is equal to 2. Similarly, for the third data, you will first press 21, that is 21. Then you will press comma and then you will press 52. If the data input is correct, you will press M plus. You will see after you press M plus, you will see n is equal to 3. That means third data has been taken. So like that way you will input all the 10 set of data. So once you have inputted all set of data, you will see the display shows is n is equal to 10. After data input is complete, now we need to get the results, right? So you will press shift 1. So that means this is the shift button. This is the shift button of your calculator. You will first press shift and then you will press 1. So when you press shift and 1, you will get this display. So sum of x square. We need to get sum of x square, also sum of x. So to get sum of x square, you will choose 1. That means you will press 1 to get sum of x square value. So after you press 1, you need to press equal button. You need to press this equal button. So after you to get sum of x square, you need to press 1 and then you will press equal. So then you will get sum of x square. The value is you will get the sum of x square value. Right. You will get the sum of x square value. After that, again you will press shift and 1. shift and 1. When you press shift and 1, you will get this display again. So now you will select 2 to get the sum of x value. So you will press 2 to get the sum of x value. So when you press 2, you have to press equal. You have to press equal to get the value of sum of x. Right. So this 2 value has been taken. Now you will press again shift and 1. You will press again shift and 1. You will get this display again. When you get this display, you press, this is the scroll button, this round button. This round button is called the scroll button. You will press right side of this right arrow of this scroll button. You will see that the display will change. You will see now that you are getting sum of y square here, you are getting sum of y here, and sum of xy here. So we will need all these value. You will get, to get sum of y square, you will have to press the button below, press the number below, and then equal. Again, to get the sum of y value, you need to press the number below and then equal. Again, to get the sum of xy value, you need to press the number below and then equal. So this way you have to get all the values, all the sums. That means sum of x square, sum of x, sum of y square, sum of y, and sum of xy. All the sums you will get from shift and 1. After that, you will press shift and number 2. After that, you will press shift and number 2. So when you press shift and number 2, you will get this display. That means x bar. So here, from here we need x bar. So to get x bar value, you will press 1 and then again equal. So you will see the x bar value will come. And then again you will press shift 2. So when you press again shift 2, you will get this display. Now we need the values for y. So again you will press this right arrow of the round scroll button. You will see that display will change and now you will get y. That means you will get y bar here and here also y, here also y. So now we need the value of y bar. So you will press the button number below y bar and then equal to get the y bar value. So after that, you will press again shift 2. You will press again shift 2. When you press again shift 2, you will get this display again. So after that, you will press this right arrow of the scroll button. You will get y here. Again, you need to press this right scroll button. You will see that here the values will be, you will get these values there. That means when you press after you press shift 2, you need to press this right scroll button twice. Then you will get this display A, B, R. So we need the value of A. We need also the value of B. We need also the value of R. I will explain you after this what is A here, what is B here, and what is R here. Okay. So this way you can use the calculator to input data and also get results from the calculator. Right. Now, if you have this type of calculator, that means, let me enlarge the picture for you. If you have this type of calculator, you will, to input the data, you have to press mode like before. So this is the mode button. This is the mode button. As you can see, this is the mode button. You have to press mode. When you press mode, you will get this display. You will get this display, right? So here you can see this is stat. This is stat. So after you press mode button, after you press this mode button, you will get this display. Here you need to choose stat. Stat means you will press number 3. You will get when you press number 3, you will get this mode. That means stat mode. After that, then after you press the stat menu, that means when you enter into the stat menu, you will get this display. You will get this display. So here, from here, you will choose a plus bx. A plus bx. That means you will press number 2. You will press number 2 here. Okay. So when you press number 2 here, you will get a plus bx mode. After that, when you choose a plus bx mode, you will get this display. You will get this display. So here, this is the column for x, or this is the column for y. So here, all the x data you will input. Here, all the y data you will input. So to input data, you need to press the data and then equal. So for example, our first data, our first data is 39. So these are the x data and these are the y data. So here x is 39. First data of x is 39. So you will press when the cursor is in the first row, you will press 39 and then equal. The cursor will move to second row. Then you will press 43. This is the second x data, and then you will press 43 when the cursor is in the second row, and you will press 43 and then equal. So like that way you will input all the data in x column. So after that you will press, this is the scroll button, round scroll button. After that you will press the right arrow to move to the y column, and then you have to press the up arrow, that means this up arrow, to go to top. When you are in the number 1 row of y column, you will press 65 and then equal. So like that way you have to input all the data in the columns. So after you finish inputting the data, you have to check whether you have input the data correctly. So if you make any mistake in inputting the data, what you can do, you can also correct it. When you check the data set, for example, you have made a mistake in some data. So you can input the correct data. When the cursor is in the data set, when the cursor is in the wrong data, you press the correct data and press equal. The correct data will be replaced by the wrong data. So after you input the data, after data input is finished, you have to press shift 1. That means this is the shift button. You can see this is the shift button, and then you have to press 1. When you press shift 1, you will get this display. Here you need to choose sum. That means you need to press 3 to choose sum. After you choose sum, you will get sum of x square, you will get sum of x, sum of y square, sum of x, y, and those things. So you need to get sum of x square, value of sum of x square, sum of x, sum of y square, sum of xy, all these values. You will get all these value if you choose the mode sum. So after that you will press shift 1 again. You will see after you press shift 1 again, you will see that this display will appear again. So now you will choose 4. VAR. That means you will press 4 to choose VAR. When you choose 4, that means VAR mode, you will get this display. So from here we need the value of x bar. That means you will press 2 to get the value of x bar, and then you will press equal to get the value. After that you will press again shift 1, and then you will choose VAR again to get y bar. So to get y bar you will press 5 and then equal to get the value of y bar. So from here we need only these two. So after that you will press shift 1 again. After that you will press shift 1 again, and then now you will choose this REG mode, that is 5. When you choose this REG mode, you will get the value of A, you will get the value of B, you will get the value of small r. So you will write down all these 3 values. We will need this value later. So this is the way you will input data. So as you can see, I have already collected all the values for you. I have already solved the problem. So sum of x for the example that we are solving, sum of x is equal to 460, sum of y 760, sum of x square is 23,634, and sum of y square this one, sum of x this one, sum of x bar is this one, y bar is this one. This one is I got this value from the calculator. Now we will calculate SXS. So SXX is equal to sum of x square minus sum of x whole square divided by n. So if you put the value there and calculate, you will get this value. Sum of y is equal to sum of y square minus sum of y whole square divided by n. If you put the value there, you will get, after the calculation, you will get this value. Sum of xy is equal to sum of xy minus sum of x into multiplied by sum of y divided by n. If you put the value there and calculate, you will get this value. Now, if you can recall, the formula for correlation coefficient was summation of SXY divided by root of SXX into SYY. So if you put the calculated value there and calculate, the correlation coefficient value will come 0.8397. Here the correlation coefficient, first you check the sign. This is positive sign, that means we get the positive value. That means relationship between x and y is positive. Now let us understand the strength of the relationship. Relationship is positive, we already know, but let us understand the strength of the relationship. Since the value 0.8397 is above 0.7, that means there is a strong positive relationship between business math variable, that is x, and business statistics variable, that is y. In other words, both x and y will move in the same direction. That is, if x goes up, y will also go up. That means if a student is good in mathematics, that means if a student have higher score in mathematics, he will have a higher score in statistics too. That means again, if x goes down, y will also go down. That means since the relationship is positive, both will move in the same direction. That means if a student with poor math score, he or she may have a poor stat score also. However, correlation coefficient fails to establish causation, as I said before. Correlation coefficient fails to give an idea that whether x is influencing y or y is influencing x. That means which was is causing who, we don't understand from correlation coefficient. In other words, it fails to give an indication whether x is influencing y or y is influencing x. So we don't get this idea from correlation coefficient. For that, we need to do regression equation. As I said before, these are the different ways regression equation is written. So y is equal to a plus bx, or it can be written, instead of a we can write b0, instead of b we can write b1 multiplied by x, instead of a we can write beta 1, instead of b we can write beta 2 xy. So these are the different way regression equation can be written. Here you can see we ignored the error term. So error term is not included. So regression coefficient, that means the other name of regression coefficient is slope. This is the regression coefficient, that is b, or if you use this equation it is b1. If you use this equation, that is beta 2. That means regression coefficient is the coefficient of x. Regression coefficient is the coefficient of x variable. So formula for regression coefficient is SXY divided by SXX. We have already calculated XXY, which is 1894. We have already calculated XXX, which is 2474. If you divide it, you get the value is 0.76556. Intercept. This is the intercept. The first one is the intercept. That means the first one, that is the term without the variable, is the, that means the constant term is the intercept. So intercept value is equal to, how we get it, y bar minus bx bar. That means y bar we have already calculated it before, we have got it from the calculator, and minus b is the slope. This is the slope, so it's there. X bar we have calculated it from the calculator, we got it from the calculator. X bar is 46. So if you calculate it, 40.78. This is the intercept. Now we will get the regression equation. This is the fitted regression equation. Fitted regression equation means after transferring the values of A and B. So if you transfer the value of A, that means 40.78, this is there. If you transfer the value of B, that is B is 0.76556, that is there, multiplied by X. So this is the fitted regression equation. So now let us understand what slope indicates. So here the slope is 0.76556. Here the regression coefficient or slope is positive. That means regression coefficient or slope is positive. That means if X or business math score goes up by 1 marks, that means if this one B is positive, that means this one is positive. That means if this one, you can see from this equation, if X goes up by 1, that means the value of Y will go up by 0.76556. As you can see, let us put the value of X as 1. If you put the value of X as 1, that means you will get 0.76556. This is constant value. 40.78 is constant value. That means if X is the 1, you will get 0.76556. That means Y will go up by 0.76556. That means if X goes up by 1 marks, Y or business statistics scores, business stat score will go up by 0.76556 marks. In other words, if X goes up by 10 marks, so if you put the value of X as 10, so instead of X, if you put 10 here, that means 0.76556 multiplied by 10, this is constant. This will always remain same. That means if you put the value of X as 10, the value will come as 7.6556. That means Y will go up by 7.6556. You can put the value of X as 10 and you can see the value of Y will go up by 7.6556. So the value of Y will go up by 7.6556 marks. So if business math, if a student get 10 more marks in business math course, that means he or she may get 7.655 marks in business stat course. Intercept is 40.78. Intercept is 40.78, which means if X is 0, that means if the value of X is 0, that means this one multiplied by X, if the value of X is 0, that means this one multiplied by 0, that means full this one is 0, that means you will get 40.78. This is the intercept. That means you will get the value of intercept when the value of X is 0. That means if the value of X, that means if you get 0 in business math, that means if the business math score is 0, even in that case also average marks obtained by Y or business stat course, that means the average marks obtained by students, business stat students should be 40.78. That means if a student, according to this regression model, it shows that if a student get 0 in business math course, he or she may get 40.78 marks in business stat. That means if a student gets 0 also in the business math course, in that case also this part will only be 0, but he may get, Y means business stat score, that means he may get 40.78 marks in business stat, even if he get 0 in business math course. Okay, so if it showed that with a very poor background on math, a stat student can pass possibly by hardworking, determination, etc., or by some other factors not considered in the model. Now we will study how we can use this forecasting, how we can use this regression equation for forecasting purpose. So forecasting using the fitted regression equation. For example, if a student got 70 marks on business math course, how much she or he can expect to get in business statistics course? That means we want to predict a student how much a student can get in business statistics course from his or her business math course. That means if he or she get 70 marks in business math, then how much she or he can expect to get in business stat course based on this model. So that means business math score is 70. That means the value of x is 70 marks. So we will put the value of x as 70 in the fitted regression equation. After you put the value there, if you calculate, you will see that the student who got 70 marks in business math course may get 94.3692 marks, that is equivalent to 94 marks in business stat course. That is predicted business stat course, business stat score should be 94 marks. This is a prediction only. Actual value may differ. So we already got the regression model and we have seen how to use the regression model to get forecast. Now we will have to understand how good the regression model is. That means the model that we have developed from the data set, how good this model is to predict forecast, to predict future. So goodness of fit. The overall goodness of fit of the regression equation or model is measured by the coefficient of determination, which is denoted by R square. That means by calculating R square, we can understand how good the model is. We can get a preliminary idea how good the model is. It explains what percentage, this R square explains what percentage of variation in the dependent variable is explained by the explanatory variable x. That means from R square we can understand how much percentage of dependent variable, that is variation in dependent variable, how much the variation of dependent variable can be explained by the variable x. That means effect of x on y, we can understand it by R square. So the value of R square can be between 0 to 1. The closer the value is to 1, that means if the R square value is closer to 1, the better the fit, that means better the model. If the value of R square is more and more close to 1, the better the fit or better the model. So in our case, the example that we were solving, the correlation coefficient value we have calculated is R value, the value of R is 0.8397. So coefficient of determination means R square, that means square of these one, that is 0.8397 square. So if you calculate it, you get 0.70509, which is, if you round it, you get 0.7051, which means 70.51%. That means, it means 70.51% variation in y, that means business stat score, is explained by x, that is business math course. That means business stat score will move by 70.51% based on x. That means 70.51% variation in y is explained by, is due to x. That means due to movement in x, y will move by 70.51%. In other words, if you deduct it by 100 minus 70.51, that means 29. In other words, 29.49% variation in y is explained by other variables that we failed to include in the model. That means we have included only x variable, only one variable, that is business math course. That we have included only one explanatory variable or x variable, that is business math course. We didn't include any other variable, but business stat scores not only depend on only business math score. Business stat score may depend on many other variables. For example, the average time spent on this course, or the number of hours spent daily on this course, or attendance. If a student attend all the classes, definitely his or her business stat course will be better. That means, and if a student regularly study, that means if a student regularly study 1 hour or 2 hour in the course, for the course, he or she will perform better. And there are other factors that may influence business stat score. That means business math course cannot be only one factor. That means 29.49% variation in Y is explained by other variables that we fail to include in the model. We have only included business math score. So now we will move to analysis of variance. So to understand how good a regression model is, we should also calculate ANOVA table. Okay, so to first of all we need to understand the components of an ANOVA table. So the first component that we need to understand is sum of squares of regression, that is in short SS and R. The formula for SSR is SS square XY divided by SXS XX. So the sum of squares of regression, that is SSR, describes how well a regression model represents or explains the model data. That means from SSR we can understand how good the regression model is to explain the model data. In other words, it measures how much variation there is in the modeled values. So you can see this is the fitted value, this is the modeled value or fitted value, Y head I. This is the fitted value or modeled value, that means forecasted value. In other way, we can say that this Y head means forecasted value, and this is the average value of the data Y, average value of the data Y. So this is the variation of the Y head I, that means forecasted value of individual, forecasted in value of individual data, and this is the Y bar, that means average of the Y data. So if you take the deviation and square, you will get SS square. But the shortcut formula for SSR is always this one, SS square XY divided by SXX. A higher regression sum of squares, that means a higher sum of squares of regression, that means a higher value of SSR, indicates that the model does not fit the data well. That means a higher value of SS square SSR, a higher value of SSR, that means sum of square of regression, indicates that the model does not fit the data well. That means the actual data we have and the model data and the model and the fitted model does not fit well. That means model is not good enough to describe the data. So that means higher value of SSR is not good. Total sum of square. Total sum of square. This is another component of ANOVA table. So total sum of squares, in short we call it TSS. It can be calculated by this formula, but this is the short formula for TS to calculate SS, TSS, that is SYY. We have already calculated SYY before, and this TSS is SYY, which is, in other way we can calculate it SSR plus SSE. So SSR we already know, sum square of regression, and now we need to understand what SSE is. So this is SSE, sum of squares of error or residual sum of squares. Always remember the synonym of error is residual. So synonym of error is residual. So sum of squares of error, that means in short SSE, it can be other way said residual sum of squares, that means SSE. The formula for SSE is this one. In short, we can calculate it. SSE is equal to TSS minus SSR. TSS minus SSR. That means TSS is equal to SYY. TSS means SYY minus SSR. We have already seen the formula for SSR is SS square XY divided by SXS. So what SSE gives us? The SSE measures the variation of modeling errors. That means it gives you the deviation, it gives you an idea about the error or deviation of the error. That means, in other words, it describes or depicts how the variation in the dependent variable in a regression model cannot be explained by the model. That means, how the variation in the dependent variable in a regression model cannot be explained by the model. That means, how bad is the model is. That means, a lower SSE or residual sum of square indicates that the regression can better explain the data. That means, lower value of SSE is good because lower value of error. Error means error is not good. Error means that our forecast is not good enough. Our forecast has some problem. And always remember, error should be as low as possible. That means, a lower value of sum of square of error or residual explains that the regression model can better explain the data. So, let us calculate the value of SSR. We know the formula for SSR. So, it is S square xy divided by SXX. We know the example that we are doing, in that SXY is equal to 1894. So, S square xy is 1894 square divided by SXX that we have calculated is 2474. If we divide it, we get this one. This is the SSR value. Similarly, TSS, that means SYY. SYY, we have calculated it before. The value is 2056. So, SSE is TSS minus SSR. That means this one minus this one. So, this one minus this one is equal to 606.0259. Right. So, now we will move to the ANOVA table. This is the ANOVA table. Here, this ANOVA table looks like this one. So, first of all, source. First source is regression. So, short form of regression is R. This is degrees of freedom. So, since in the regression model we have used only the x variable, number of x variable is only 1. The number of x variable or the explanatory variable is, or the number of independent variable is only 1. That's why the regression, degrees of freedom for regression is k is equal to 1. That means k is the number of independent variable. That is, we have only 1. And this is the column for SS, that means sum of squares. And since this is the row for regression, so R, that means here we will have SS and here this is R. So, SSR. So, here we will have the value of SSR. We have already calculated the value of SSR, which is 1449. This one. This is the row for error, that is in short E. So, degrees of freedom for the formula for degrees of freedom for error is equal to n minus k minus 1. We know for the example that we are solving, in that example n is equal to 10. That means we had 10 data set. So, n is 10. Minus k is 1. That means 10 minus 1 and then minus 1. So, formula is error degrees of freedom is n minus k minus 1. So, 10 minus 1 minus 1 is equal to 8. This is the column for SS. And since this row is for E, so we will have SSE here, SS, and we will have E here. So, SSE, we have already calculated it, 606. This one. And this one plus this one should always be TSS, that is 2056. That is, we already know. See, SSE, you can see from the previous page, TSS is equal to SSR plus SSE. That means, in other way, SSE is equal to TSS minus SSR. That means this one plus this one should be equal to TSS. So, is equal to 2056. So, now we will move to this column, MS. That means mean sum of squares. So, this is MS means mean sum of squares. So, MS, and since this is the row for R, so we will have MS and R. MSR, the formula for MSR is equal to SSR divided by K. So K is the number of independent variable. We have in our model number of independent variable is only 1. So SSR divided by 1, which is SSR. That means this one will only this one will be there. Now we will move to, this is the column for MS, this is the row for E, so we will have here MSE. So MSE, the formula for MSE is equal to, always remember, so these, how we get this one divided by this one is this one. Again, this one divided by this one is equal to this one. So that means this one is 606.0259 divided by 8. That means here this one divided by this one, that means this one divided by 8 is equal to 8, this one, right? So now we will move to the final column, F statistic. So F statistic is equal to, the formula for F statistic is equal to MSR, that means this one divided by MSE, that means this one. So MSR, this one divided by this one, that means is calculated 19.14. And degrees of freedom for this F statistic should be, you remember we divide this one by this one. So obviously degrees of freedom will be 1 divided by 8. Since we divide this one by this one, we will also divide, to get degrees of freedom we also have to divide 1 divided by 8. So degrees of freedom is 1 divided by 8. So this one is called numerator degrees of freedom, 1 is called numerator, 8 is called denominator, right? So 1 is numerator degrees of freedom, 8 is denominator degrees of freedom. Right. So now we need to move to F table. F table. So this is the F table, right? This is the F table. If I enlarge it for you, this is the F table. I will give you this table. This is the F table. You can see F distribution. So F table, right? So this table, in this table, let me enlarge it for you. You can see numerator degrees of freedom. So in here, in this row, you will have numerator degrees of freedom. So in this row, you will have numerator degrees of freedom. In our example, numerator degrees of freedom is 1. So that means we will have to look at so this is numerator degrees of freedom. So numerator degrees of freedom 1 is here. So we will have to confine ourselves to this column only. Now we have to look for denominator degrees of freedom. Here the denominator degrees of freedom is 8. So in the F table, so denominator degrees of freedom should be 8. So you can see this is the denominator degrees of freedom. Here denominator degrees of freedom is 8. So denominator degrees of freedom is 8, right? So here, first of all, to get the value from the table, you need to understand confidence level first. If we are confident that, if we are 95% confident that our regression model is good, that means if we are 95% confident that our regression model is good, then level of significance means how much error we are allowing. If we are 95% confident, that means we are not confident is only 5%. If we are 95% confident that our regression model is good, that means we are only unsure, that means we are only allowing 5% error. That means level of significance is 5% or level of error is 5%. That means in Greek term, this level of significance is denoted as alpha. That means alpha is 5% or in decimal 0.05. So that means, as we will move to that here, so numerator degrees of freedom in the F table, numerator degrees of freedom we have is 1, and denominator degrees of freedom is 8. So denominator degrees of freedom, see, denominator degrees of freedom is 8, and alpha, this is the value of alpha. Always remember, these are the values of alpha. Here the value of alpha, this is 8 degrees of freedom, denominator degrees of freedom is 8. So we will move to here, and column is this one, numerator degrees of freedom is 1. So this is the column, and denominator degrees of freedom is 8. This is the row, and the value, these are the, we have 4 values of alpha here. This is, here the alpha value is 0.01, 0.025, 0.05. And for our case, the value of alpha is 5%. That means level of significance, since we are 95% confident, that means we are allowing 5% error. That means level of significance, or the value of alpha is 5%, which is 0.05. That means we will, this is the 8 degrees of freedom, denominator degrees of freedom 8, numerator degrees of freedom 1. So we will see now the alpha value. This is the, for our case, the value of alpha is 0.05. So the area is 5.32. So the table value, or the area table value is 5.32. So from F table, for F, that means this is the alpha value for F 0.05, that means alpha value 0.05, and degrees of freedom is 1 by 8. This way, exactly this way we have to write is 1 by 8 degrees of freedom. The value we get from the table is 5.32. So this is the value, 5.32. Now here F statistics value we got is 19.14. So here F statistic value is 19.14, which is greater than this table value. So table value is 5.32. So F statistic value is greater than the table value. So F statistic value, that means calculated value of F, is greater than the table value of F. So what it means? So it means, so therefore we can conclude that the regression model is statistically significant in predicting the effect of variable x. Now we will solve another problem on this. So example 2. A famous multinational electronics company is planning to enter Bangladesh air condition market with their product. They have collected air condition sales data, that is in $1 million per year, at different prices offered in Bangladesh. They want to develop a regression model for their most popular AC product, which is 1.5 ton AC, to predict its yearly sales. Following data set depicts or describes yearly sales data for similar 1.5 ton AC products sold in Bangladesh at different prices. So this is the 1.5 ton AC prices in Bangladesh. These are the values of AC air condition price, the 1.5 ton air condition price. All these figures, that means all these data X, are in thousands. So that means this one is 75,000, this one is 73,000. You can see this is 1,000. So this one is 70,000, 68,000, and so forth. So that means all these X data is in 1,000 taka. And this sales data, that means yearly sales data of 1.5 ton AC is Y. This data is in $1 million. So this is $38 million, this is $45 million, this is $54 million, and so forth. So that means we have X data. So we are assuming that if price of 1.5 ton AC, that means if price of AC goes up, demand for AC or sales of AC will fall. That means if price of AC will go up, sales of air condition will fall. That means with the increase in price, demand for AC will go down. That means the sales of AC may also go down. So that means there might be a relationship between price of AC and yearly sales of AC. So this is the data set we have. You can see we have total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have total 15 set of data. So that means here n is equal to 15. So if you input the data in the calculator like the way I have taught you, if you input the data and get result, you will see sum of x is equal to 998, sum of y this one, sum of xy this one, sum of x square, sum of y square, x bar and y bar. So these are the results you will get from the calculator after you input this data set. So here the question is asking in this example, the first question is first question the example 2 is asking is find correlation coefficient, that means Rxy, and interpret the result. Second question is asking find regression coefficient, intercept and develop a regression model and interpret the findings. Find goodness of fit and interpret the outcome. Develop ANOVA table and model significance at 95% and 99% confidence level. So 4 questions we have so far. So first of all, we need to find out we will solve part A, correlation coefficient. The formula is there, you know the formula. So first of all, you will calculate Sxy. So summation of xy minus summation of x into summation of y divided by n. If you put the value there, you will get the summation Sxy value. Similarly, you will get the value of Sxx. Similarly, you will get the value of Syy, this one. So now correlation coefficient. So Sxy divided by root over Sxx, Syy. So if you put the calculated value there and calculate the correlation coefficient, it is minus 0.98062. Here you can see the relationship is negative. That means there is an opposite relationship between x and y. So from the sign you can understand there is an opposite relation. Negative means there is an opposite relationship between x and y. So let us turn over the page. Interpretation of this one, correlation coefficient. So correlation coefficient is, we got minus 0.98068. So that means there is a strong negative relationship. From this one shows that negative relationship, and since the value is more than 0.7, that means strong negative relationship. There is a strong negative relationship between price and yearly sales of air conditioner in Bangladesh. In other words, both AC price, that is X, and yearly AC sales, that is Y, will move in the opposite direction. That means if price X goes up, AC sales Y will go down, and vice versa. That means vice versa means opposite is also true. That means if price of X goes down, if price of X goes down, AC sales Y will go up. Now we will solve part B, regression coefficient. You know the regression coefficient formula for regression coefficient is xxy divided by Sxx. If you put the value there, you will get this one. So intercept you can calculate it y bar minus bx bar. So y bar we have calculated this one, minus b is this one is there, multiplied by x bar we have calculated it from the calculator is there. So if you calculate it, see minus a plus. So if you calculate, you get 292.2366. So now we'll develop the regression model. So regression model y hat is equal to, you know the regression model means y is equal to a plus bx. So a means a is this one 292.2366 and b is minus 3.4114. So a plus bx means a, and then b, value of b is minus 3.4114 into x. Interpretation. Here regression coefficient or slope is negative. That means if price of AC goes up by 1000, that means if price of AC goes up by 1 unit, here 1 unit means AC price is in 1000, so that means 1 unit means 1000. So if price of AC goes up by 1 unit, that means 1k, that is 1000 taka, yearly sales of AC will go down by this $1 million. So that means you can see, if you put the value of x as 1, that means if you put the value of x as 1, that means this one multiplied by 1 means minus 3.414. That means the value of y will go down by this one. So first you put the value of x as 0. If you put the value of x as 0, that means this one is 0, that means y is this one only. Now if you put the value of x as 1, you will see that 1 multiplied by this one means minus 3.4114. That means the value of y will go down by this much. So that means with every increase in x, that means with 1 unit increase in x value, the value of y will go down by 3.4114. Why down? Because there is a minus sign there, because regression coefficient is minus. That's why with every unit increase in x, the value of y will go down by this much. So that means the value of y is in $1 million. That means with every increase in x, that means with every unit increase in x, the value of y, which is in $1 million, that means value of y will go down by this much $1 million. So again, if price of AC goes up by 1 unit, that means 1k or 1000 taka, yearly sales of ACY will go down by this many unit, that means this much $1 million, and vice versa. That means vice versa means opposite is also true. That means if price of AC goes down by 1k or 1 unit or 1000 taka, yearly sales of AC will go up. That means if price of AC goes down by 1 unit, yearly sales of AC will go up by this much unit or $1 million. Right. Now let us interpret intercept. Intercept is 292.2366. That means here if the value of x is 0, that means this one multiplied by 0 means full, this one is 0. In that case, the value of y is this much. That means intercept means if price of AC that is x is 0, yearly sales from AC will be in that case this much. That means yearly sales from AC will be this $1 million. But what the logic says, if the AC price is 0, in that case you will receive no revenue. How can you receive revenue if the AC price is 0? If the price is 0, that means you are not getting any price or any revenue from selling the AC. That means you are not getting any revenues. That means how come you are getting this much $1 million from sale? So that means the intercept in a regression model is really a number with any direct economic or physical meaning. That means this value of intercept really means anything. Right. So now we will move to part C, goodness of fit. That means we want to get a preliminary idea about how good the model is. So coefficient of determination we will do it, that is R square we will calculate. That means R square means R whole square. That means the value of R was this one, so whole square, if you square it, that is minus a plus, that means square it 0.96161, that means 96.161%. What it means? Thus 96.161% variation in Y, that is Y means yearly sales from AC, is explained by explanatory variable X. That means 96.16% variation in Y is explained by variable X, that means price of AC. In other words, that means it is saying that 96.161% variation in yearly sales is due to, explained by means is due to movement in price. That means 96.16% variation in yearly sales of air condition is due to change in price, In other words, 100 minus this one, that means 3.83% variation in Y is explained by other variables that we fail to include in the model. Price of air condition is not the only one variable that can affect yearly sales data, because that other variables can be like income of the people. If for a particular, for example, now in our country we are having, we may have a recession in future due to this coronavirus outbreak. That means even if the companies reduce the price of air condition, this is the peak season for air condition sales, because now the temperature is going up in our country. That means we are getting more and more heat in our country. So this is the peak season for air condition. So even if the companies those who sell air condition, even if they reduce the price also, air conditioning sales will not be much, because many people they do not have job, many people they do not have business, they do not have good amount of earning, and many people are scared to spend now on luxurious food, luxurious items. So that's why many people will think twice to to spend money on air condition. So that means even if they reduce the price of air condition, many people will not buy it now. So that means income of people economic condition of our country can also be a factor behind the yearly sales of air condition. So that means price of AC cannot be the only factor. So that means, in other words, 3.8% variation in Y is explained by other variables that we failed to include in the model. In our model, we have included only one explanatory variable, that is only one X variable, that is price of AC. But there may be other variables that have impact on yearly sales data of AC. Now we will move to part D. So here we will calculate SSR. So you know the formula for SSR. We will calculate, we will put the value there. TSS means SYY, we know the value. SSE means TSS minus SSR. That means this one minus this one. So it is there. So now we will move to ANOVA table. So you know the ANOVA table. So this is SSR. This is the SSR. That means here K is 1 because we have only one X variable. X variable is only one. So that means only one explanatory variable or only one X variable. That's why K is 1. So you know that this is SSR, and MSR means this one divided by this one. So this one divided by 1. So this one. And SSE is, you know, SSE, and this is error degrees of freedom. N minus K minus 1. Formula for error degrees of freedom is N minus K minus 1. So here N is number of data is 15. K is 1 minus 1, which is 13. So MSE is equal to this one divided by this one. That means this one divided by 13, which is this one. Now F is MSR divided by MSE. That means MSR divided by MSE. So this one divided by this one. So if you calculate it, this one. Degrees of freedom, since we are dividing this one by this one, so degrees of freedom is 1 divided by 13. 1 divided by 13. If you get the value from the calculator, if you get the value from F table, if you get the value from F table, you will see, say, confidence interval is 95%. If the confidence interval we use is 95%, that means we are allowing only 5% error. That means level of significance is 5%. That is alpha is 5%. That is in decimal 0.05. And if we are using 99% confidence level, that means level of significance is only 1%. That is 0.01. So from F table, you know that how to get value from F table. So F for alpha 0.05, and degrees of freedom is 1 by 13, 1 by 13. That means numerator degrees of freedom is 1 and 13 is denominator degrees of freedom. So if you get the value from table, this is 4.67. Again, if you use alpha as 0.01, so that means alpha is 0.01 and degrees of freedom is same, 1 by 13 degrees of freedom. If you get the value from table, F table, this is 9.07. Here you can see F statistics value. F statistic value is, the calculated value of F is 325.64. So 325.64. F statistic value 325.64 is greater than F value. That means greater than the table value of F. That is 4.65, 4.67. Again, this one is greater than also 9.07. So that means we can conclude that the regression model is statistically significant, that means statistically good in predicting the value, in predicting the effect of price of AC, that means in predicting the effect of X on variable Y at both 95% level and 99% level. That means since the calculated value of F is greater than both the table value, that means this is 95% confidence level value, this is 99% confidence level value, and calculated value of F is greater than both the values. That means our regression model is statistically significant, that means statistically good in predicting the impact of X on Y at both 5% and 99% confidence level. So that's the end of this chapter.